So we're ready to start. Thank you for being here at this session, which is on is focused on data representation and accessibility in Rubin LSST. You can find here some information that you can find also on the website of PCW. This session is is focused on how to get a more inclusive science communication, improve accessibility of the results. Let me thank also the co-organizer of this session, which are remotely connected, apart me. Andres Plazas Malagon is also remotely connected. They will give a talk after my introduction. And Sabina Usamuic, who's also submitted the proposal for this session, and Laura Venuti and Sally McFarland that are remotely connected as well. And so the agenda for today is my introduction of the data visualization and representation subgroup activity. This is a subgroup of transient variable stars science collaboration, TVS. Then Andres will give his talk on accessibility efforts and plans with the Rubin's community science team. And we also have here Gloria as a representative in person of the community science team. And then another invited talk by Riley Clark. We'll talk about Ruby Rhapsody, sonification of Rubin data for enhanced exploration and accessibility. And then we will have time for discussion. So I will start with a reminder of code of conduct. During this project community workshop and Rubin in general, harassment and unprofessional conduct, including the use of offensive language, is not allowed. And you can report any issue to Andrew, John, and Alicia. And using this QR code, you can download the full code of conduct. If you feel unsafe, there is an email that you can contact. And please check the name tags for contact, comfort level stickers, and for someone wearing the pin like this one, the social battery indicates, if it indicates a low social battery, you please give them space or offer to continue conversation at a later time. And for virtual participation, please be sure to be muted where you're not speaking. But of course, you can unmute yourself and make questions. We prefer to use Slack channel for conversation, for messages, because in this case, we can keep record of the discussion. And Laura, which is welcoming us from remote, and Sally will help us monitoring Zoom, chat, and Slack channels. For participants in person, please use the microphones. Both this and those located on the table should work. So to let people remotely connected also to hear your question or your comments. And okay, I will start on data visualization representation subgroup activities, which is a group of transient variable star. I am Sara Bonito. I'm a staff researcher at the Italian National Institute for Astrophysics, the Observatory of Palermo in Italy. And I'm giving this talk on behalf of the co-chairs from remotely connected, of the co-chairs of this subgroup, Sabina and Sally. You can see Sally here. Sally is a postdoc fellow at the South African Astronomical Observatory, and Sabina is a postdoc fellow at the Observatory of Palermo. The aim of this subgroup is to support and promote research into multidimensional visualization and sonification of Rubin LSST data. This is the newest group in transient variable stars, but this could be relevant to other subgroups in TVS, but also to other science collaborations in general. And that's because visualization and sonification, so a different representation of data could be very important in the epoch of big data and multidimensional analysis. And this group aims also to focus on the investigation of the effectiveness of the representation using these new technologies. And this one. Okay. In this slide, you can see some example. This is on the exhaustive list. And of course, the inputs from you, not just now during this session, but also continuing, could be in touch in the future, could be crucial for us. Here you can see that for today, we will show you just some of the new technologies that can be applied for representation, which are virtual reality. Okay, sorry. Okay. Virtual reality and augmented reality, 3D models that can be printed for a more inclusive science, and data sonification and digital domes. Seems like, okay. So let's start with the part focusing more on the virtual reality representation and 3D models. Our team mostly located in Italy, and you can see here a list of people involved in the project focus on variability on young stellar objects with Rubin LSST. We have started working on a program for inclusive science and 3D models to make more accessible our results to visually impaired students and researchers for scientific dissemination, but also for education and outreach. And that's when the new subgroup of TVS started the activities, because our team, starting from the Observatory of Palermo, developed already in the past some 3D models that could be printed to enhance the accessibility to the results to vision impaired students and researchers. And the project focused on both the investigation of variability in the light curves in the same filters as future Rubin LSST data using existing archives like PanSTARRS, Gaia, ZTF, and also focusing on the development of 3D models and rendering that can be printed. And here I show you the light curves of a variable young stars as an example, but this can be applied to many diverse scientific cases, so variable stars. And you can see some details on the variability in this case of an accretion disk, also discussed in the poster by Alessandro Tramuto that you can see here outside, and I hope you see him presented in the flash talk today, and is also here. So we have developed expertise in studying 3D magnetohydrodynamic models, so very detailed models, but also simple renderings, starting from an astrophysical object and developing the 3D models that can be shared in public galleries in a platform like Sketchfab that you see here, some example produced by our team that can be also visualized in the virtual reality and augmented reality. And the visualization in augmented reality, in virtual reality, is shown in this movie. In this case, it's a stellar jet. You see also in this case the interaction also of exploding stars and supernova remnants. That in fact, you can see that we provide this here some links in the Sketchfab galleries for different cases, some based on scientific astronomical objects like the universe in hands, but also the art of astrophysical phenomena or the science of science fiction. And also virtual reality app focus mainly on exploding stars and supernova remnants has been developed. And this is also a free app that can be used. So the 3D rendering and visualization in virtual reality can be made with different purposes. In this movie, you can see a detailed numerical model of an accretion disk in this case. And this represents a scientific representation with accurately physical phenomena. And so the target is specialized scientists. And this has been developed by Salvatore Orlando, our colleague in Palermo. But depending on the target audience, also, maybe you barely see that here, sorry for that, an artistic representation of the same accretion process. In this case, this could be used for outreach because it's not focused on the scientific details, but also this can be used to develop rendering in 3D that can be then printed. And the printed objects that represent these astrophysical complex systems are very useful for accessibility for visually impaired students and researchers, but also for everybody, because these systems are so complex that when you see a 3D model on a 2D screen, basically you lose a lot of details. So everybody will take advantage of using, seeing or touching 3D printed models. And we are starting now also new tools, investigation that will allow us to use virtual reality of 3D astrophysical models, also not just for visualization, but also to start a detailed analysis in virtual reality, which is a very an immersive experience, but it will be useful also to perform scientific analysis. And here again, I'll show you some models that can be printed. We will publicly make available these objects as far as we develop that on a catalog. And again, you can see there the accretion disk, which is a very, it is based on a very detailed numerical model, but also simple rendering of rotating star with a spot on that because of a shock formed as an example can represent very simple objects. And this is an example that has been printed by NASA for us as a test, but this is also good for internship for undergraduate students. We have done this in the past, starting analyzing light curves and then testing simple 3D printed objects locally. And we are now organizing also school for undergrad students, but also for researchers in general. This one will be in Palermo in September this year. It will be an Italian national school, but can be also converted in the international school in the future edition, maybe. And the steps are to start from the exploration of photometric light curves, to reproduce the 3D models, both for virtual reality and augmented reality, and to develop 3D renderings that can be printed. Okay, so let me spend also a few words on digital DOMs, which is the main topic of Sally. And from these movies, you can see on the left here, galaxies, and on the right is a rendering of the brain of a mouse. Again, seeing this in a 2D screen is not as complete as the immersive experience in a digital DOM. But this will allow to perform a deep exploration, in particular for discovering and using big data of big service like in future with Rubin LSST we can do. So please keep in touch with the co-chairs, this subgroup, Sabina and Sally. You see here the emails, but also there's a Slack channel, which is TVS DataVis. So we can continue this discussion within the Slack channel and in the future. Today, we will start a discussion about these new technologies and the application, but we would like to collect more ideas on how to complete the list of new tools that can be used for that. And I will stop here. So thank you. Any questions? Yeah, I will give the mic.
Thank you. I have a sort of question comment. For those of you who don't know me, I'm Sophie. I've been working on the analysis tools package for the stack. A lot of the graphs you have seen in various talks have been from analysis tools. And we did put quite a lot of effort into trying to choose colorblind-friendly color schemes. I got my colorblind friend. He thought he was coming over from dinner. I made him look at 100 plots. He's not a scientist. He just wanted food. But he gave me his approval, or he wanted to get to food. I don't know. But I would greatly appreciate any inputs from this kind of thing. Or if you look at the plots that you see in various of the talks and you say like, no, I can't tell these points apart, or you've done something really stupid here. Any input sent our way. And also to encourage people to use the standard plotting framework we're trying to build so that we can build this stuff in at a basic level. And then everyone has access to an easy like data visualization suite that has accessibility built in. So please talk to me and give me feedback.
Thank you very much. This is a crucial aspect for us. In fact, we also we test our models with colorblind person and students in the University of Palermo to do so. And we would like to make all of these resources available for colorblind people in general. And the next topic will, the next talk will cover also this topic for development of Python notebooks, let's say the use of colorblind tables friendly. Yeah, thank you very much.
If I can add on this topic, there's a number, colorblind, of course, we want to be colorblind compliant. There's also a number of other neurodiversity issues of perception that we can think of, and we could give best practices to, you know, people that give Rubin talks, and maybe we can fold them into the PCW recommendations on like what fonts to use, what size of font, you know, letters to use, how to make thoughts that are more legible for different perceptive abilities.
Thank you. Yeah, thank you. Any other comment or question? Okay, if not, we will now have a talk by, sorry, let me check whether there is, Is there any question from remotely connected people? Sally?
There are no questions.
Okay.
remote.
Do you want to add something, Sally, on your topic?
Yeah, sure. There we go. Hello, everyone. Yeah, I'm speaking from Japan, which is why I'm very grateful to Sarah for giving this talk. So thank you very much, Sarah. And yeah, we're very excited to have you join us today and to also talk. I also like to second what was said about the accessibility. That's also something that, I mean, it's one thing to visualize the data, but also we need to consider how we interpret the data and how everyone interprets the data. I think that's very important. Yes, no, so Sarah briefly mentioned my work with digital domes. So if anyone has any questions about that, it's still a very new field. I've also been working with groups who worked in not only visualizing data in VR, but also looking at the statistics behind it. How do you analyze data in VR? And that analysis of the data is also something we're looking at with digital domes, and it's still a very uncertain field. So if anyone in this room has any idea how we use digital domes or modern planetariums for the analysis of data, that's also something we're working on at the moment. Yeah, so I encourage anyone to ask any questions. I look forward to the next two talks. And I'll be monitoring the Slack channels. Thank you.
Thank you, Sally. Yes, there is a question here. You can turn the microphone. Oh yeah, you can also turn on the microphone there. If it's green light, it works.
Oh, there we go. Is that working?
It only amplifies in the back after the window.
Okay, good. Yeah, so we have a blind person at Penn who gave a talk on sonification, which you mentioned. I was curious whether there are any sonification applications. That's a different way of, I guess, representing, not visualizing the data that is useful even just as a primary analysis tool where the sonification works better than a visualization.
I don't know whether Riley will cover this. Do you want to answer now?
Yeah, so I think this is an interesting topic about sonifications over whether or not they should be considered like complements to visualizations, or rather they should be like the primary mode of interpreting the data. Obviously, for blind and visually impaired persons like that, that is the only mode that they can access the data. But yeah, I'm not sure of any like specific examples where sonifications are preferred, are all else being equal, being preferred to visualizations. I think they work. I think an idea is that they work best as complements to each other.
I mean, the obvious one might be like some kind of time series data, right? Where like you could maybe hear a chirp, right? I mean, the gravitational wave is the obvious one that we've all heard now.
Right.
But
and I'll show some other examples in my talk. Yeah.
Great, thanks.
Okay, thank you. And so, Andres, I see you are connected. Do you want to share your screen and give the talk?
Yes. How's the sound? Is it good? Can
It's
you hear
good
me?
on
It's good on Zoom. And what about over there?
Yes.
Yeah, we can hear you.
Okay. So Gloria, you don't have to give the talk. Thank you very much for being back
Oh,
up.
she's here.
I know she's there. She was gonna be the backup. Unfortunately, my flight got delayed, canceled, weather, so I couldn't be there. But that's okay. That's life. Am I sharing the screen that I think I'm sharing? You see the slides?
Yes, but not in presentation mode.
Like
Yes, for us.
Okay, thank you.
that?
You can start.
Okay, perfect. Just 1 second, please. I have like 3 screens here. Okay. Yeah, thank you, everyone. Sorry I couldn't be there in person. My name is Andres Plazas Malagon. I'm a calibration scientist half of my time, and the other half of my time I work in the community science team. And I'm gonna give a brief talk about the accessibility efforts in the Rubin community science team. So the first part of the talk is gonna be explaining what the community science team is, and maybe you've seen these slides already. So within Rubin operations, we have all this organigram, and then we have the Associate Directorate for System Performance. And within that, we have the community science team alongside verification and validation and other important departments. So the system performance department is responsible for ensuring that the LSST as a whole is proceeding with the efficiency and the fidelity needed to achieve its science requirements at the end of the 10-year survey. And the community science team is part of this department because the scientific results that the community are going to produce are a key success metrics for the Rubin Observatory system. So we are the part that is going to ensure that the scientists and the users that are going to utilize LSST are going to make the best out of it. So these are my colleagues from the community science team. We have expertise in documentation, citizen science, and the different science pillars of the LSST. And within the community science, we have what we call research inclusion, although this is a more broad effort within Rubin. If you heard this morning's plenary session by Bob. So within research inclusion, and this is a slide that I stole from Gloria, we want to remove barriers to participation in LSST. So there have been efforts to give, for example, prioritized access to this data previews to those who identified as underrepresented in astronomy. There are many efforts about recruitment of researchers at small institutions and minority institutions, and Gloria has done a lot of these efforts, and she can tell you more about that. Within these efforts, we also wanted to start more activities in order to increase accessibility to Rubin data, to LSST data. So this is where our work comes in. We just relatively recently started to implement this in a systematic way. And for that, we have what we call an epic. So for those of you who work in the Rubin Observatory project, you're familiar with terms like JIRA, epic, tickets, blah, 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 blah. This is, if you're not familiar with the Rubin Observatory, that's fine. This is just a way in which we have to track our work, right? And then eventually probably our amazing managers make a one-to-one correspondence to the funding agencies, and then everybody's happy. But that means that every single unit of work that we want to do, we need to make a ticket for that. So why am I telling you this? Because this is important. We have a bunch of tickets related, like several tickets related to accessibility. And this means that there is time, and that there is funding, and there is money invested in this. This is part of my regular job, it's part of our work. And I wanted to make an emphasis on this because usually efforts on accessibility or things like these are considered as an afterthought, and that needs to change, of course. We need to put this as a priority. So within that, now having explained JIRA and Agile management in 2 seconds, so we have started these efforts of accessibility and universal design within the community science team. There is, on this slide, I have on the right side a screenshot of a Confluence page that we have, and I don't think everybody has access to that, so I didn't put the link, but if you're interested on details, just talk to me and I can give you more details. And we have started by doing a literature research about resources to write and implement guidelines in different aspects in which we think we can improve accessibility in Rubin. And by literature research, we have looked at the reports by the International Astronomical Union, the American Astronomical Society, papers, because there's already a lot of literature on this topic, and we shouldn't be trying to reinvent the wheel. So we have done investigations on topics such as universal design, neurodivergent astronomers, hearing impaired astronomers, vision impaired astronomers, for example, in implementing the blind and visually impaired friendly choices in our documentation and presentations. Just like a few minutes ago, somebody was mentioning, I think it was Sophie and others were mentioning about implementing this type of guidelines. So yeah, this is let me talk about, I wanted now to talk about some examples of the type of guidelines that we've been trying to implement. So for example, for alternative text, we have found a series of guidelines in which people that are writing tutorials for DP0, they can find these resources in one place, and then we start to standardize this in a single place. And I think again it was Sophie or somebody else mentioning that it would be great to have something that is standardized, and then people can go back to these guidelines and then follow these guidelines in order to implement them. So this is, I just put here some examples of this type of guidelines, such as when you're writing an alternative text description for an image, you should be brief. If it's possible, you should spell out acronyms. You should avoid using jargon, etc. So there are specific guidelines of people who have thought harder about this. And one thing that of thinking of this approach is to put yourself in the user, and I'm gonna say something more about this. And then again, Sophie again talked about her friend going through all the pictures and to see if they were fine. But you put yourself in the person who are going to use this, and if they're using a screen reader, for example, so it would be better if they don't encounter acronyms or things that are not defined. And I think that's kind of the logic behind this. So this is just one example of these alternative text guidelines that we have tried to implement in our tutorials for the data previews. So we have tutorials in the different aspects of the Rubin Science platform, like the portal aspect and the notebook aspect mainly. This is an example of one of the tutorials in the portal aspect. This is the, I think this is the first tutorial or the second tutorial, in which you access one image, then you have an alternative text description of that. So that's just a screenshot of an example. Another thing that we wanted to make an emphasis into looking for guidelines were Jupyter notebooks. And for this, luckily, I got input from people in Rubin, like Federica and others in the TVS collaboration. And then we started, so we use a lot of Jupyter notebooks, of course, but from an accessibility point of view, they're very inaccessible, especially the interactive part. And if you're trying to think of how a person with a screen reader would go to a Jupyter notebook and trying to figure what's going on out, then that's kind of, it's troublesome. So it's going to be a little bit hard. So we also find out that there were colleagues in other institutes in astronomy. For example, in the Space Telescope Science Institute, we found colleagues that have been also thinking about this same type of problems. And one set of guidelines that we found is something called the Notebooks for All project. And I put a link to there, which is a collaboration between the Space Telescope Science Institute and then other collaborations in order to write a set of guidelines for increasing accessibility in Jupyter notebooks. One thing, for example, again, I'm not going to go again into every single detail, but like I put some examples here and some ticket numbers associated. If you're curious, I guess the tickets are always public. You cannot just edit them, but you can read what work is being done. Anybody can do that. And one example is ensure that the contents of the notebooks is available in other formats, for example, as a HTML page or other types of formats, which again is not the best, is not maybe the final solution, which we're still looking for that and we need to keep striving towards that, but it gets us a little bit closer to make things more accessible. These are just examples of a couple of guidelines regarding Jupyter notebooks, but we have a list of more. Again, in one of those technical notes that I mentioned before, this technical note, Rubin technical note 045. Another thing that was done by the Space Telescope Science Institute was an accessible notebook hackathon. And this is part of an effort of making these things second nature and to changing the culture in astronomy. Gloria, who's there in the audience in person, she attended this hackathon in March, I think, yes, in which they dedicated like a couple of hours to go through notebooks and then go through these guidelines. And then if you have a notebook that you wanted to work with, then you would bring it, and then you would work on that with other people, like in the dark science, like in the dark energy science collaboration, we do these sprint days. So it would be like something like that. Just people sit down and work together. We're thinking about doing something similar in the fall with the DP0 delegates. There's about 600 delegates that have access to the DP0 data right now, focused on the tutorials that we have in the different aspects of the RSP. So stay tuned. And if you want to know more about this accessible hackathon that happened, there is a link to the recording of the event. Another topic that we've been exploring is data sonification. That, of course, we have a lot of experts right here in this audience. So there's a lot of work done within Rubin, and again, in other places like the Space Telescope Science Institute. So they pointed us to a page called Astronify that I put a link there. There is the Rubin Rhapsodies project. So I am pretty sure that we're going to hear more about this in the next talk by Riley. Within the community science team, for example, we would like to develop a DP0 data sonification tutorial or demonstration. And then here we start getting into the question of how do we use this type of data representation as a research tool by itself. One of the things that we found when doing our literal research is that there's a lot of ideas for education and public outreach, which is great. And if you know me, you know I love education and public outreach. At the same time, since I'm with my hat of the community science team, we're like serving scientists, and we want to see how these tools can be used to do research, which is related, I think, to the question that Mike was asking before, Mike Jarvis, there in the audience. So this is in the plans. We haven't done that, and I'm looking forward to learning how to do it. I think this ticket is assigned to me as well. Then one thing that also came in our research and talking to other people is the need for focus groups for testing, or like how do we know that we're actually producing something that's good? And that's another question that I would like for us to brainstorm about. Then again, I've been mentioning my colleagues, or our colleagues from the Space Telescope Science Institute. Their names are Scott Fleming and Jen Kotler. I don't know if they're actually part of one of the science collaborations. They might be. They have emphasized the importance of involving and compensating astronomers with disabilities during the testing process of guidelines, of the implementation of these guidelines. And in their experience, they have done asynchronous and anonymous surveys. They have done one-on-one interviews, and they have partnered with other organizations. They gave me an example, one organization called Glass Education, which they put them in contact with blind and visually impaired astronomers, and then the Space Telescope Science Institute compensates them, and they have this partnership in order to do that. Then I would like also to point out this report by the Working Group on Accessibility and Disability by the AAS, by the American Astronomical Society. They wrote a document related to publication. It's called Improving Accessibility of Astronomical Publications. And they also have this same type of recommendation about using focus groups with different users for the target audience. In Rubin, we're still working ways in which we can fund this and incorporate this and try to make the case of how this is an important thing to do and that we should be doing as well. Then to finalize, thinking of accessibility in terms of removing barriers, in terms of research inclusion. If you look at the dictionary definition in English, is the practice of making information and activities and environments sensible, meaningful, and usable for as many people as possible. So recently I was reading articles and doing some research on the cost of the barrier that science, that English might represent for people who are not native English speakers. And there are studies on this, and I would like for us, or in the community science team and also in the Rubin community, to think of ways in which we can mitigate these barriers. Chile is one of the main partners in this project as well. For example, in terms of Spanish, for example, but I mean, you know that this is a very international collaboration. Something small that we have done recently, I said, okay, why don't we just translate the Rubin glossary and acronyms to Spanish, which has like 3,000 terms. And we're doing that slowly, but it's happening, and we got funding from Rubin to do that. That's a first step. We are also thinking in ways in which which barriers are there and what could we do in order to help with this, especially for early career researchers and junior researchers. I think that's it. I think there are more. There's more stuff that I didn't mention that I had in that Confluence page that I mentioned at the beginning, but I would be more than happy to give more details. But I wanted to finalize with some questions for discussion. Some of them I already mentioned them. How to include and adequately compensate focus groups for usability testing in the context of Rubin, like working alongside astronomers and LSST users with disabilities. This is something that, again, people, I think we need to be compensated properly, and you might need some institutional review board approval or something like that, because of course you're dealing with people, and that's always delicate. But I mean, this is something that can be done. So that's one thing. How can we foster, there's a typo, propose, there's another typo, sorry. How can we foster, propose, and sustain a culture of accessibility within Rubin and lead these efforts within astronomy in general? And I think one of the things that makes me proud of working for Rubin is that we are gonna be changing astronomy, at least optical and infrared astronomy, but we're gonna make a huge impact in astronomy, and we are in a position of leading this type of change of culture. So I think hopefully we can make use of that superpower. Another thing is what kind of metrics can be defined to assess progress and success. This is another very tricky question, like that I don't know exactly the answer, but I think it's an important, very important question. Like 4 years from now, how do we know that these guidelines are actually having an impact? Then come to my mind things like the TMAP report, or I'm pretty sure that people smarter than me that have thought about this harder. But I want to encourage the community to think about this how could we quantify our progress and in which timelines. Then another point that I wanted to make is how can we better interact with our colleagues from other centers that are thinking about similar problems, like I mentioned several times, the Space Telescope Science Institute. So I don't know, maybe we should make a joint workshop or something, or yeah, try to see, because they're probably facing similar challenges, and maybe we can all share ideas of solutions. Then to finalize, I would like for us to think about the relationship to similar efforts that might be happening at the same time in the Rubin education and public outreach level, which, as I said, this is great, and there's a lot of resources in education and public outreach. In the community science team, we're interested in the part not in education and public outreach, but the science facing users of LSST and how to use these tools for doing research. But I'm pretty sure there's a lot of synergies, and I think in the previous talk they were mentioned, or they were asking a question about this. I think that's it. Please let me know if you have any questions, and looking forward to hearing from your ideas.
Thank you, Andres.
Yeah.
Questions around this? You want to use your own microphone then?
Yeah, Andres, great to hear so much progress on this. Something that occurred to me as you were saying, how can we foster like a community of practice on this, specifically within Rubin, is that a lot of us are probably called to referee papers that are based on Rubin and they're related to Rubin. And each one of us has the power to actually help the editors make sure that these accessibility goals are met. So when we referee a paper, if we see that the plots are not designed according to the guidelines that you have given, I think the editors would welcome us speaking up. And in my experience, they always do. Like whenever I pointed out colorblind, non-compliance, etc., I've always got praised by the editors.
Yes, yeah, thank you. And I think I also try to do that in the internal review process of the Dark Energy Science collaboration has a style guide, and there's a section about this type of thing, like encourage the authors to make plots that are friendly for blind and visually impaired people, and there are tools online in which you can upload your plot and see how it would look like under different types of impairment. So yes, but this is something that always, you're right, like it should be always in the back of our minds, and we should try to find our sphere of influence. We have talked in the past years about this concept of sphere of influence, and even if we're not in the manager or we're not professors, there's always something that we can do. Either you're mentoring an undergrad, or yes, you're called to referee a journal, a paper. So think about the ways in which you can enact this change.
Any other question for Andres? Otherwise, let's thank Andres again, and we'll move to next speaker, which is here in person, is Riley. We'll talk about sonification. Maybe you should watch. Yeah.
Yes.
I think there is a question from Sally. In the meantime, Sally, do you want to unmute yourself?
Yes. Hi, Sarah. Just to, no, it's no questions, but a great talk, Andres. Thank you very much. There's no questions online, but I just want to mention that we have set up the closed captions. So if anyone wants to read along, and we apologize, our apologies for not setting that up earlier.
Yes. Okay. Let me try stopping the screen share and oh, it's my Wi-Fi connection has failed.
Waiting on that. We all want those captions here because individuals can turn it on their own computers. It's up to you.
I think it was asked for people in person. That's
Oh, in here. Oh,
yeah.
oh, that's fine.
It was asked
Just making
for
sure.
this.
So, is your
I think we're back. Okay. All right. Hi, everyone. I'm Riley Clark. I'm a graduate student from the University of Delaware. And for the past couple years, I've been part of a team called Rubin Rhapsodies, which is a project to enable and provide access to the LSST data through sound. And we take an interdisciplinary approach by using the expertise of both astrophysicists, but also musicians in collaboration with Lincoln University, which is the first degree granting HBCU in the United States. So I'm here representing the University of Delaware component of our team, along with Dr. Federica Bianco, and our Lincoln University counterparts are Dr. Christine Lim, Jindaya Wells, and Faranmi Adepoju. So sonification, put simply, is the representation of data with sound, as opposed to the more traditional representation of data that we're more used to, which is visualizations. And sonifications can be complementary to visualizations. They can enhance our ability to engage with the data in that way, but they also provide access to people who can't access the data in any other way. And also, sonifications sound cool. They're a novel way for us to engage with astronomical data in a new way. Okay, so I wanted to begin by showing one of our sonifications of a type 1bc supernova without any explanation, and just let the impression just kind of set in, and then I'll break down all of the choices and design behind it. Okay, so let's hope this works okay. Okay, I'm not sure I'm not sure if that came across the speakers okay, but okay, great. Yeah, so there's a lot going on in what you just heard, but a lot of the decisions that informed this sonification was inspired by Dr. Christine Lim's oh, I need to share my computer sound. I'm sorry. I think I should be sharing the computer sound now. Test. Okay. Okay, so I'm gonna go ahead. There's more sonifications later. So okay, yeah, we can play it one more time. Okay. No, so our setup is a little weird. It's just I have to have my computer sound on for it to come through on Zoom. But a stereo component is another way that we can map data onto sound. So, but it's unintentional in this case. Yes. Yes, they are. Let me. I'll get to a slide about that. So our the musicians on our team, when we were developing the sonifications, their perspective on it was that, first and foremost, any sonification has to be faithful to the data, to the quantitative component of the data, and that the data, but once you have preserved the quantitative information, then you can start working on listenability and making sonifications that are memorable, distinctive, and expressive. And to that end, incorporating musical elements like motive, melody, and drones. And that last one might be a little unfamiliar to some of us, but drones are a common component of musical composition. They take the form of a sustained sound or repetition that serves as the tonal foundation for the piece, and they're found in all kinds of music across cultures. The bagpipes from Scotland or the tanpura from India. Okay, so why should the Rubin community be interested in sonifying LSST data? First and foremost, this is an issue of equity and research inclusion, and the LSST would not be complete without including those who can't access visual information. But also, the Rubin data is highly complex and multidimensional, and offering complementary representations of the data in concert with visualizations enhances our exploration of that data. Now, sonification has been used before to represent astronomical data. The folks at Space Telescope Science Institute have developed Astronify, which is a Python package for sonifying astronomical data. I'll go ahead and show an example of a planet transit that is sonified using Astronify.
Listen to the star.
Okay, so yeah, so you could definitely hear that dip in pitch as the exoplanet transits in front of its star. Additionally, there have been sonifications of images, such as this image taken by the Chandra X-ray Observatory. All right, okay, cool. So that's pretty cool, right? But you know, Rubin data is not just light curves and images. You know, it's photometry in 6 different bands and all of the associated metadata that goes along with it. So this is a very rich a rich field for sonification. Now, of course, there's no Rubin data isn't available yet, but we do have the opportunity to sonify Rubin-like data, specifically from the photometric LSST astronomical time series classification challenge, otherwise known as plastic. And indeed, you know, we have fluxes, different bands, uncertainties, and a whole host of metadata. And so the question is, you know, how do we map these different parameters of the data to characteristics of the sound? And what are the choices that we can make in that sonification space? So we created this diagram to illustrate the different possibilities that exist in the parameter mapping space. And so we have aspects of the photometry on the left side, and then different musical aspects on the right side. And the solid arrows indicate the parameter mappings that we used in our sonifications, but the dash lines represent alternative pathways that could also potentially be explored. And so the thing that photometry and music have in common is that they're both time series, right? So time is the baseline that they both share. But we map the brightness to the pitch of the note in the sonification. And we map the uncertainty to the volume of the note. And so that points with larger uncertainties have lower volumes and so are diminished compared to the rest of the notes in the composition. And the different LSST filters are represented by different instruments. So the tonal quality of the note is being mapped to the passband. But there's a lot more that can be explored in this space. I mean, it's not just photometry, there's also astrometry. The coordinate of the source can be mapped potentially to the spatial direction of the sound. And there's also the properties of the sky during the observation, such as the moon luminosity. And this is indeed what we decided to map to the drone that serves as the foundation of the sonification. And of course, yes, there's more metadata also. So there's a lot of the possibility space is quite large here. The software that we actually use to do the sonification is called Sonify. It's a Python package that lets you convert tabular data to MIDI files. MIDI is a technical standard for electronic instruments. And the software lets you control the pitch, volume. There are 119 different instruments to choose from. You can even write your own keys that the data is mapped to. And you can have single tracks or multiple tracks played simultaneously. So our choice of mapping different instruments to different bands is what we call the orchestration of the data. And this was what our colleagues at Lincoln University, their musical expertise was employed here. So the sonification that we do is done in the Lydian mode. And this is a where the fourth note in the octave is raised by a half step, which gives it a kind of brighter sound. And we chose to use brighter sounding instruments for the higher frequency band passes. So we have the U and G bands being represented by the clarinet and trumpet, and then the I and Z by the cello and the French horn, and the Y band having some different photometric properties. It kind of justifies an entirely different choice in instrument, and it's being represented by bells. Okay, so I'll play two different sonifications of a single band, the G band, which is being represented by the trumpet, and then the Y band, which is being represented by, again, the bell. Okay, so that was G-band. Okay, so that was, sorry. Okay, so that was Y-band. That one was pretty quiet. But hopefully you could hear those three notes, that those three kind of chimes during the event. And then this is what you hear when you play all 6 bands together. And then finally, the last piece of the composition is adding a glissando drone in the background that is mapped to the phase of the moon over time. Okay, so then, and now it's hard. Okay, so in that one you might have been able to hear this kind of pulsation in the background. That is the repetitive drone that represents that is mapped to the moon illumination. Okay, yeah. So that's Rubin Rhapsodies. I'll end just by again emphasizing talking about the partnership between Lincoln University and UD as part of the Delaware and Mid-Atlantic Science Corps, and that this project has been funded by the Heising-Simons Foundation and the NSF. And one of the products of this, one of the deliverables of this project is a glossary of terms to further future collaborations between musicians and astrophysicists. All right, thank you.
Thank you, Riley. There are questions for Riley? Yeah. You want to use the microphone there? Yeah.
Hi. Cool. I didn't think I was ever listened to the word Lydian scale in a work conference. I feel trapped by music theory now. It was an ambush. Can I ask, this is a genuine question, right? Can I ask how many scientists empirically use data sonification in practice as contrasted with the kind of 3D monitor technology that creates like a tactile display of graph? I'm not sure what the proper word for it is, but you know what I mean, is the thing that raises pins or lowers pins depending on the data representation. That I am aware of at least one person who's using that. So I'm kind of curious which of the alternative data visualization forms are actually like out there in the wild right now, as opposed to like, you know, things we could do, but nobody's necessarily using them yet.
Yeah, I think tactile representations are also like really interesting. But I think what sonifications specifically are really really appropriate for are time series, because they're both things that vary in time. As far as you know, the fraction of scientists that are actively using sonifications as tools in their research, I'm not sure about that.
Sorry, to be clear, and I mean off visually impaired. I don't mean like the whole
Right.
population. I mean the people who are currently working with these challenges. What are they currently using for data visualization?
Yeah, so I think in terms of actual sound representations of data as a tool, my understanding is that like that's probably pretty rare, and that sonifications offer a way to engage with the data less than offering an actual utility for the BVI community to actually perform data analysis in that way.
Okay, thank you.
Other question? Yeah. Yes.
Hi, Riley. Thank you for this. This is lovely. I'm wondering, working on this for a long time, have you identified any areas in the realm of sonification that like where do you see this going?
Yeah, so I'm definitely interested in the kind of the public outreach aspect of sonifications. I think there have been some examples of things making the round in like press and in social media of I think also like NASA did a sonification of a black hole. There's also, of course, the chirp of the gravitational wave discovery, and this does serve as a way to kind of engage the public and spark interest in like, oh, that's like a new way of that's a little more, maybe more interesting than just looking at a plot. And in some ways that is almost more art than science. But I think riding that line between art and science and finding ways to engage people in kind of a new way is where I see it going.
I just want to say that makes a lot of sense, and I also want to give props to you again because the difficulty of the task of sonifying a time series almost seems simpler than sonifying an image like you showed, but I think in practice it's much more difficult, right? You have so many more variables in the metadata that you discussed. It feels almost impossible to come up with a satisfying sonification technique, but I feel like you did it. And whenever I listen to these, I close my eyes and I try to get as much information as I can. And it's always very exciting. And I feel like it is well on its way to becoming a useful tool.
Thanks. Yeah, and it is certainly a challenge, especially when considering that the plastics data is unevenly sampled. So you have to contend with data that is not being at a steady cadence, and you have to figure out like, okay, well, do we represent those time gaps in an exact way or not?
Yeah, obviously I should have asked my previous question on this talk. I didn't realize. But no, kind of to reiterate on that though, I think a really interesting part of research on sonification is like, what are the things where your ears work better than your eyes? And I don't know if you want to say any more about that after now we've heard some, but I feel like there must be some, and I really look forward to when there are things that get discovered because of sonification rather than just having it be like an outreach tool. I think it's going to happen, but maybe you can say more.
No, that's definitely interesting to me too, and that kind of follows on from Willow's point. Is that that's another direction in taking advantage of the sensitivity of the human ear, and which it is more sensitive than our eye to small changes. So yeah, I think that is another pathway for future applications of sonifications.
What a question there, and then
Yeah, I was just seeing. Okay, can you hear? One of the things that strikes me is sometime this year, relatively recently, I read something that was basically a plea for consistent coloring in visual representations of data. And it seems like that becomes a much harder problem here. Like having to explain the glossary to be like, well, if you hear a horn, that's the green band, without any standardization. Like that seems like it's an extremely hard problem if you want to start representing a wide array of data that you can then compare. If you need a particular decoding key for each sample, like how do you address that?
Yeah, so that is absolutely a challenge with sonification right now, is that there is no kind of universally agreed upon standard for sonifications. So and there are probably a lot of reasons for that. Probably, and one might be that, you know, sonifications are not necessarily considered as are kind of considered as an afterthought, or more, or kind of decorative in a way, rather than being like a as legitimate representations as visualizations. So so I think there is a need for a sonification standards to be developed and kind of promulgated, not just in maybe the Rubin community, but in, you know, the broader scientific community.
Question here, but you want to use it?
Can I just add something to that? That I think that you're right. You're exactly right. The root of the issue, but for which there is no standardization, is that we're not accustomed to sonification. We have standardizations in visualizations because we all use visualizations. So it comes with the history, and we barely had them, right? So you're saying that there's a plea to have more standardization and more, you know, codification of how to do things in a way that is more intuitive to everybody and more homogeneous. That's the same for sonifications. They're more unusual, so less standardized. And this project was going exactly in that direction. Like, can we provide one standard like curves? Sure there is. There's a network tapti of everything, right?
Yes, Igor, please.
Yeah, Federica kind of, this is Igor Andreoni, and Federica kind of introduced a comment I wanted to make, which is that we have, in general, a huge bias towards anything visual over anything sonification. Like, we rarely spend more than a few minutes saying, oh, this is cute that a light curve can be sonified, and we move on. So I'm actually wondering if any experiment has been conducted, perhaps using, say, students that maybe are not accustomed to classifying astronomical sources. So for them, this bias is a little bit less pronounced, and perhaps actually move away from standardizing even the sonification, but tweak the parameters such that perhaps the classification of sources via sonification beats the classification that people can do visually. And perhaps, yeah, maybe by using Gaussian processes or something to also make the symphony maybe easier to listen to.
Yeah, I think any development of sonifications will probably be incomplete without actual human subject testing, focus group testing. And I really like the idea of kind of a competition between visual interpretation and sound interpretation.
If I can mention one study exactly along those lines, is recently done by Anita Zanella, and I know it because I was one of the referees of the paper. So, you know, first of all, there's not a lot of attention to this literature, so I probably would have not known if I wasn't the referee of the paper. So I'm sure that there are other studies that, you know, I didn't pay attention to. But for the most part, they are single band. So these studies uses Astronify and transients, planetary transients. And so, yes, that exists, the quantification of the effectiveness and efficacy of sonification compared to visualization and sonification plus visualizations among both the blind and visually impaired community and the sighted community for single band light curves. For multi-band light curves, it's a whole another level of complexity.
Yeah, but that's where sonification can win, right? Because our ear is much more sensitive to variations and so on than our eye. That's at least something I heard in other similar workshop as this.
Right.
one.
So as Riley mentioned, we're very sensitive to small variations with our ears better than we are with our sight. And sonification help in highly complex data sets. We can hear to multiple, you know, we kind of like hear in series, but we see in parallel, right? So, you know, we can absorb multi-dimensional light curves at once with the sonification, not really with the visualization, not as effectively. But it's harder to study and it's harder to set standards, and it's a more recent discipline.
I see here there was some comments online. So one is by Andres, Breadpoint by Mike. So before, maybe something to discuss also in the discovering the unknown session. So this is a comment. Then there is a question from Sierra, but you're here. Would you like to make your question?
Sorry for making you zoom around. So I guess I was curious briefly about, it seems like sonification will still require us to develop additional tools to help people, because we can't rely on people having perfect pitch in order to recover the information about exactly what the flux is. And I was wondering if there's any thoughts about how you might want to approach that, because this seems great for feature recognition, but not necessarily for like writing the paper after.
Yeah, I think this goes back to talking about the sonifications as a way to engage with the data, and then sonifications as an actual tool for data analysis. And I think that is kind of a next order of requirements that you would need to actually make sonifications useful and even more useful than visualizations for data analysis. So I think that should be an aspect of any sonification standards that are developed. More rigorous standards for sonifications as tools for data analysis.
Yes, please.
Yeah, but we don't actually use visualizations either to determine the exact flux of an object. We use them that's kind of the same way to engage with the data, right? We use that to plan our data analysis. We use that to get a comprehensive sense of the data, but we don't, measure the delta magnitude by making a plot and looking at it. So I think in that sense, that's the same issue with sonifications and visualizations. Although I take the point that, yes, people with perfect pitch might have a better ability to determine what the mapping between what they hear and the true number is.
Yeah, to follow up on that, I mean, there's both sides of visualization. Like sometimes after you realize something by writing code to figure something out, you brainstorm a visualization to present it really well to either public in the talk or in a paper. I think the same could apply to a sonification. Like once you've figured something out, if you realize sonification is a good way to present it, you can then craft a really good, connection of pitches and volume and whatever else that would make the point you're trying to make.
There is also another comment online. Is from Gregory. I wonder if these sorts of sonifications will become more usable, understandable, research friendly, if we could provide sonifications of a set of reference signals based on simulated data and exploring a variety of different cases, accompanied by screen reader friendly description of each case. It is when you hear something that sounds like this, it represents that scenario.
Yeah, thanks, Gregory. Yeah, I think that's interesting. I think that's another role sonifications can play as complements to screen readers. I think, well, I mean, screen readers themselves are sonifications. They're guides for how to navigate text on a screen. But that is really difficult, right? How to have sonifications that provide context to an analysis to actually, rather than just representing quantitative information. I think trying to represent like the context and of what's going on with sound is much more challenging.
I can read another comment online from Agnes. Very interesting. Any plans to sonify alerts? It could be an outreach tool in this case to convey many transient phenomena of many different types happening one night.
Yeah, that's a cool idea too. I think I think sonifying the sheer volume of alerts that are released per night is a daunting challenge. You know, I can imagine a symphony of millions of alerts being played all at once. But you might go mad listening to that. But yeah, that's a cool idea.
Yeah, this is a question over there.
I'm sorry if I missed. Does it work? Okay. I'm sorry if I missed this, but I wonder if you have talked to any visually impaired people about their experience and how they might use this, and what's their thought in terms of developing sonification data.
Yeah, thanks for that. So that is unexplored territory for this project, is kind of that kind of focus group testing with blind and visually impaired persons. I did have a conversation with Scott Fleming, who is the developer of the Astronify software package, and he did mention to me that some of the feedback he's gotten from the BVI community, specifically about MIDI instruments, is that that MIDI is not necessarily the best way, is not necessarily a great representation of sound for actually interpreting some quantity compared to just a pure tone. So, you know, that might be something that we come across, that, you know, maybe the mapping things to MIDI instruments is cute and artistic, but is it the best way to convey quantitative information in a useful way? Maybe not.
So we are 5 minutes before the end of this session, and I've prepared just some questions. Let's say, as I was saying, the conversation on this is starting today, but will continue on the Slack channel of. So we can continue talking on that. Maybe we can share some new ideas for these new technologies, these new tools that can be applied for sonification on 3D printing, so multisensorial representation of the astrophysical systems we want to explore with Rubin LSST. And if any of you now or in the future would like to see or hear their projects in 3D with sonification in the digital dome, please contact us so we can develop new systems. We just show you today some applications of that, and we can continue collaborating on that. And so what would you like to see in 3D to hear through sonification? And of course, if other science collaborations are interested in join us, I started talking about a subgroup of transit variable stars, but many other science collaboration could be involved in that, or any other stuff. So from today, we discussed it a lot, and so I thank you for all the inputs, but I'm conscious of time, so maybe we can continue the discussion at the later stage, and thank you for being here.